Hello, everybody. I'm Abasud, and welcome to my course on communication and network security. So, let's go to the agenda. In the previous section, we have discussed about the secure networking models, which consist of OSI model and TCP/IP model majorly, and we have discussed about the complete thing. What are the risks? What are the attacks? How we can mitigate that? All those things. So, in this course, we'll be discussing about the second module, I would say. So that is the secure network design. So let's let's start with this module. What is say before we start for the module, so it must be remembered that this course is about network security, not just about the network architecture and being a network administrator, but rather how we as security managers should provide oversight and leadership to ensure that our networks are secure. Now networks have evolved a lot over the years, so let's discuss how the networks has evolved from where it has started and then now where it is. So the evolution of networking starts, of course, back with the old days when we have a crossover cable that could connect two devices rather, and that is the definition of network: two or more devices that can communicate. We have many different types of network. Even today we have two devices that connect very often with a wireless personal area network, such as Bluetooth headsets talking to personal mobile on their wrist. This was truly a circuit because as a circuit it is direct connection between those two devices. But what happened when we needed more than two? Well, we put it on a hub. A hub allow us to connect a number of different devices in what we'll call as a peer-to-peer network. This was the original definition of peer-to-peer networks, and a hub could support maybe 8 or maximum 12 devices before network congestion become a problem. The problem, of course, with the hub is that each of those devices heard all the traffics of other devices. Everything was communicated as if it was a bus. So if I set my NIC, my network interface card, into into a promiscuous mode, I could capture all the traffic that was meant for other people that were communicating on that time as well. But this is just a type of circuit. It's a direct connection. There's no circuit switch here because we are not doing any switching until we change the hub out of a switch. We when we then change it out of the switch, we could connect switches together as well. So we could now have two different networks that could then route network effectively within each network as well connect to other network. And the definition now comes in of a local area network, a rather unclear definition because a local area network is very often a few devices within a fixed geographical location. But we all knows that in today's world of software definition networking, a LAN can really actually be a number of different locations, but they work together as if they were one physical location and one physical LAN. But a LAN, that is local area network, allow us to now to be able to centrally manage all of the devices on a switch. And the advantage of course is that traffic now from one device to another get routed directly and is not easily picked up by the any other devices on that the same network, unless we are running on span port, for example. So basically the disadvantage which you have seen in the hub, like all the devices is listening to the traffic, every traffic, because it's moreover like in bus prototype they were using. So here in the switch, like we can connect to different networks, and it not able to listen the traffic for the device. So we also had bridges to connect networks together as well, but that connection between two networks could be local, or of course it could be over another telecommunication provider services. And that connection between two switches could now become what we called a wide area network. In the earlier days of internet, we established calls from a modem to modem that that were often called point point to point type of connection. Okay, so here we have seen like these are the switches. So in this slide we have just looked on the modems, how we are communicating. We are having a device which is connecting to a modem, and then we are having a point to point lease line. It is connecting to a separate modem, and then my modem is again converting the signal to the device that we were using previously during the call. This is also a circuit allow us to be hmm, often that is called a point-to-point network. This is also a circuit that allows to be able to communicate not over a cross cable like we did earlier, which was all digital, but now we can communicate over voice grade telephony services. That meant we could put a demoderator or modem, so we could convert the digital signal of the desktop into an analog signal, so over the voice network, and then we convert the modem at far end back from an analog signal to a digital signal. One of the problem, of course, with these earlier networks, especially running over the phone lines, was that they had a lot of noise in the noise and static, because voice could handle a little bit of noise and static, and we have learned to ignore it when we were on the phone. But that was not good for digital, so we had to put in parity bits to try to make sure that we have correcting, or at least error connection detection on our traffic. And then we saw a computer say, well, I have a head office in Cleveland, I have a branch office in Columbus, I need those two offices to be able to talk to each other, and I don't really want to use a modem. So instead we would go to the phone system, we would lease a line, and that was very, what we call that, a private network, because it was for a private use of that one client. It was not shared with anybody else, and it had a lot of advantage because a private network, you did not have to worry about the congestion or other people using it, and it was a little bit hard to tap into or eavesdrop on. We also know that all of our network followed that route, and so it can very dependable. It may not be a great service, but at least it was always the same level of service when we have a lease line like that. But that came the idea, let's connect out of a large network, maybe internet, maybe some other type of packet switching network, and now our desktop would connect to DTE. DTE refers to other data terminal equipment, to the channel service unit of telecom provider, which then would connect us to the larger internet. So this is what we are showing in this second diagram. Our systems are connecting to DT, data terminal equipment. Data terminal equipment is connected to CSU, that is the channel service unit, which is a device of a telecom provider, and then it is getting connecting to the internet. And now we start to see the development of packet switching networks, so that now we could connect over the internet and connect over other type of packet switching type of devices, so that now traffic did not follow one committed dedicated line, but could find its way many different interconnect nodes from the origination to the uh, termination point. So the traffic in such case did not take a shortest path. It took whatever was the best path available at the time of the communication and the time of that individual packet. Now the problem with that would not necessarily come reliably in the right sequence. Sometimes they would be fast, sometimes they would be slow. So we saw that some companies say, yeah, but we want the reliable service we had when we have a circuit packet switch network. Since it's shared, everyone saw sort of it carrying a bit of the cost of it and so on. Instant of you paying for the one copper circuit that went right from end to end for a private use. You pay for 7 days a week, 24 hours a day, even if you were closed on weekends. But now, how could I have a switch level service on packet switch network? And that was by defining by route my traffic could take. So therefore we define a circuit, we would define a path, but we would call it a virtual circuit, or many times a permanent virtual circuit that my network would always take. So this is what we are having as a like how a network evolves. So let's go forward and we look into the what are the different communication protocol. So let's discuss about what is a communication protocol. What do you mean by a protocol? So there are a lot of different protocol we use. One of the best definition I could heard of a protocol is like a language a person could speak. Can be Hindi, English, French, German, Italian. Each language has its own rules, has its own format, and some languages frankly are better at communicated than sometimes the other, where they're more precise. And we do the same things with the network communication. We have communication protocols or protocol or communication language. And when we started into the idea of packet switching networking, the first one really was something we called data packet and X.25. 25. It was an international standard and it was in use for over 30 years. You will still see some of it around in some places. In X.25, I could connect my traffic to go through this. It was data only, but it was the beginning really of what then later become the things like frame relay and ATM, that is asynchronous traffic mode, and of course multi protocol level switching. The idea of X.25 was it was a great on voice grade cable, and that meant it had to do error correction at each time along the way. So each stop between say Cleveland to and Columbus, now it would stop, check that the things were okay and in each of those towns along the way it would make sure that the error was detected and fixed before it's passed to pass it on further. But as we saw the evolution from voice grade cable to fiber, we didn't need that anymore. We could now take out the error correcting and only do that on the endpoint. So we saw the great increase in the speed and flexibility when we went to our frame relay and ATM protocol. As we looked at the earlier on layer 2 traffic is called frame. So you can see exactly what frame relay did. It would relay layer 2 traffic from point to point across this packet switching network. ATM said we can make things a lot faster by defining a fixed cell length for all of our traffic. So instead of having variable size packet or frame, everything is exactly the same. We can speed up our processes. It's just much more efficient. And then we came up with MPLS, that is multi-protocol label switching. So now we could send different types of protocols, but by putting labels on them, we could then govern or control the route they would take. So we could ensure that traffic went and on one type of network instead of another. So the thing is that we could sort of saying that protocol operate at a layer, but that really quite fictitious because a lot of protocol actually operate at various layers, and so that the rules are not possible. So we are now something called MPLS, that is multi layer protocol. It is very good argument. So this is what we are having. So in the next session, we will be discussing about the